So, okay, so does anybody have any questions? Worksheet 3, worksheet 4, or those Alex practice problems? I like to go with these myself because, we don't really look at all of these topics in class. A lot of these are just on, strictly on Alex, and now we can ask questions about them. So are there any problems that anybody would like to take a look at?
Yeah, number 23.
23, okay. Thanks, yeah, that's good. Yeah, all right. 23.
Yeah.
So, and this is potentially this is one of the problems that could show up on your in-class portion of the exam as well. This is one of the things that overlaps with what we've done. So, yeah, this is a good problem. Negative, or the opposite of log base 5 of x minus 4 equals 1 minus log base 5 of x minus 8. Okay, so what should we do? What could be our first step here?
We move the log and the room to the
Which log?
log base 5 x minus 8.
Yes, good. So we'll add that log to the other side. We want to get all the logs on one side and then everything else that is not a log to the other side. That's one approach. Okay, and I'm going to write the positive log first. So I'm going to write log base 5 of x minus 8 minus log base 5 of x minus 4. I like to write the positive one first so we can see which one's positive, which one's negative, and then, tells us which is going to go on top, which is going to go on the bottom. Okay, so next, what do I do?
You're going to combine the logs.
Combine the logs. And what would the two logs combine to be?
This would be log 5 x minus 8 over x minus 5.
X minus 4?
Yeah.
Yeah, good. All right, nice. And then what?
Change it to exponential form.
Change it to exponential form, and what would that be? 5 to the power 1? Very good. Uh-huh. We solve for x. How would we solve this for x? Very good. Nice. All right. And so 5 to the first power is just 5. So we'll distribute that and we get 5x minus 20 equals x minus 8. And we could subtract x. Add 20 on both sides. 4x equals 12. Good. And so x equals 3. If we divide by 4 on both sides, x equals 3. All right. Everybody good with this? There is a way to check it. Yeah, and so that was kind of a trick question there. We should check it. How do we check this, or what do we need to check for? If it's a true statement, yes, we need to do that. I mean, that would be good to check, but there's something else at a minimum that we have to check with these log equations. We have to make sure it's not an extraneous solution. How do we know if it's an extraneous solution? That's right. The argument cannot be negative. So if this 3, if we plug it into any one of the original logs and we get a negative argument, then this is not a solution. Hey, this comes out to -5. Can we take the log of -5?
No.
No. So that means that this is an extraneous solution. That means that there is no solution. Yeah. Very good. So, and there are the answers in the back here, so let's double check because just to make sure. No solution. Okay. Good. Oops. All right. So that was a good problem there. I'm going to make 02D next to it, just say we did that there. All right, cool. What other problem? Yes. 28. Yes. The mass of a radioactive substance follows a continuous exponential decay model. A sample of this radioactive substance has an initial mass of 292 kilograms and decreases continuously at a relative rate of 18% per day. Find the mass of the sample after 5 days. Okay, and then do not round any intermediate computations. Yeah.
But this one going with like formulas,
Yes.
would we have that on the?
No, no, you won't be given any formulas. So there's only a couple of formulas that you have to know for this one. One of them is, well, and they've come up on the worksheets. If you remember on the worksheet, there was like the value of some heavy machinery is given by this equation. V of t equals V sub 0 times 0.8 to the t. Right? It would say like, and I can pull it up real quick. Was it this one? No, it was the next one. The heavy equipment loses 20% of its value each year, and then the value was modeled by this equation here. Right? So we have a similar situation going on here. Now I just wrote that. This is loses 20% per year. I wanted to write this down because that 20% per year that it's losing is 1 minus 0.2. That's how they get the 0.8. It's 100% of the value minus 20% of the value. That's where the 0.8 comes from. So we have a similar situation here. It says it decreases continuously at a relative rate of 18% per day. Okay. Yeah, so what is the formula for this one? Yeah,
Said continuous, so it must have the E, right?
yeah.
Isn't it like? Is it like A equals something E to the power?
Yeah, there was one like that, P e to the RT.
Yeah.
Yeah,
It's
E-
just, space, right? 2.7.
yeah, remember the base of the natural log, this is approximately 2.7. It's kind of like pi, being 3.14. 2.717 is approximation for E. So it's just a special number that comes up, an irrational number. Yeah.
For Alex, you're gonna have to calculate if the option.
Yes. Any problem that requires a calculator, like this one where it says round to the nearest tenth, you will be given a calculator on it. Yeah. Okay. Now, since this is decreasing continuously, I'm going to put a negative on this on the rate. And so we get A equals, what's P stand for?
It's principal.
Yeah, the principal or the initial amount, right? And so that's 292 kilograms. I'll leave the kg off. E to the negative 0.18 times T, and T is 5. And so we can punch this into a calculator. Let's see. Do I have a calculator? Does anybody have a calculator? Make sure, you're comfortable using the calculator that you have, I haven't used this in a while, but then we get 118.718 grams. Okay. All right, so I'm assuming you saw something similar to this when you were working on your Alex homework. Yeah, so, all right. What else? Did that make sense there? Yeah.
Add a negative.
Because it told us that it was decreasing continuously, so we put a negative in front of the rate. Because a negative, remember that the exponential function, the basic one that we looked at was like this. Let's just call it f of x, equals e to the x. And so if you want it to be decreasing, one way to do that is to graph the function g of x equals e to the negative x. We make the exponent negative, that will reflect it about the y-axis and make it a decreasing function instead of increasing. Okay, and so that's how you put that negative, because, yeah. And then also another key there that somebody mentioned, it said continuously. And so that's why we ended up using this e actually, rather than using this formula rather than some other one, which might come up in a different problem later. All right. What else? Number 4?
Yeah.
Yes. Let's see here. Number 4. Yeah. So for number 4, we want to look at the function f of g of x. And remember that f of g of x can be written as, in this way, f of g of x. So whenever you plug in a number into the function f of g, it's like plugging it into g of x first, and then plugging that output into f. So let's try plugging in a value into the function g. We'll plug something in, we'll get an output, and then we'll plug that into f. What values can g take as an input? Yeah, 1 is a value. Yeah, if you look at the domain of g, yeah, any value in there. Let's start with 0, and then we'll do 1 next. We'll do them all, I guess. But
0 amplified, right?
No.
yeah, so let me see. F of g of 0, that's going to be f of g of 0. Can somebody tell me what g of 0 is? 4, right? Does everybody see this arrow here? Going from 0 to 4 on g. Yeah.
0 to 7 and not
Okay, so
0 to 7.
f of g of 0 is 4. Somebody just said 4. And now this becomes now the problem. What's f of 4? F of 4 is 4. Yeah, good. There you go. So this is 4. That means that for this function f of g, when you plug in 0 as an input, the output is 4. And so what that tells us is that the domain does include 0 and the range does include 4. Okay. Does everybody see that? I plugged in 0 into f of g and I got 4 out of it. Okay, let's try another one. F of g of 1. F of g of 1. Well, yeah, so we're going to split this up into 2 problems. F of g of 1. So what's g of 1? G of 1 is 1, yes. Right? We can see that g sends 1 to 1. So instead of g of 1, we can plug in 1. And now what's f of 1? F of 1 does not exist. If you look at the domain of f, meaning the domain of f, it says it right there. There is no 1 in there. So because f of 1 does not exist, or it's not defined, then 1 cannot be an input for f of g. And so I'm not going to include 1 as in the domain of f of g. So, and then we just continue in this way. F of g of 2. So we ask ourselves, what is g of 2? G of 2 is 0. And can we find f of 0? It's 5. Good. So 2, 5. You can plug in 2 into f of g, and the output is 5. So that means 5 is part of the range of f of g, 2 is part of the domain. All right. Is that okay so far? Yeah. So let's just try the other ones. I'll just do them with the picture. How about 7? Is 7 included in the domain of f of g? Okay, 7 gets mapped to 3, and then 3 gets mapped to 5. So that does work. So that means 3 and 3 gets mapped to 5. 5 we've already put in the range of f of g, so we'll just leave it as 4 and 5. And what about 8? 8 gets mapped to 1 under g, and then f of 1 is not defined, right?
Oh, why did we put 3, not 7?
Ah, you're right. We should have put 7, yes. Yes. Yes, there should be a 7 here. Not 3. Yes, thanks for that. 7, wow, what the heck? I did it again. Oh, yeah. Okay. 7, yeah, 3 cannot be in the domain of f of g because it's not even, it doesn't even, yeah. Okay. Okay, so then the last one, 9. 9 gets sent to 8 by g. 8 gets sent to 4. So then 9 is part of the domain. And then 4 was part of the output value. So here are the domain and range. Yeah, you really just have to walk through each of those. Right? Yeah, it's not, huh? Ah, 0, 2, 7, 9 and 4, 5. Zero, 2, 7, 9, 4, 5. Good. All right. What else? What else do we want to see? 26. Yeah, let's take a look at it. All right. Yeah, this is a good one. Okay. So there are 2 ways to solve this problem here. How should we start? Does anybody want to?
Are we doing, which one are we doing?
Number 26.
You can get the, put, 100 in exponent small. And
Good.
then you solve it as like, what do you call it? An equation, whatever.
Yes. So, yes. 100 is 10 squared. So instead of writing 100 to the 7 minus 7x, I can write 10 squared to the 7 minus 7x. And then if you remember your properties of exponents, these exponents can be multiplied together. So this is really 10 to the 14 minus 14x equals 10 to the x squared minus 25x plus 44. And there is a property of exponential functions that says if you have 2 exponential functions set equal to each other, and the bases are the same, then the exponents must be equal. Okay, there was a similar one for logs. So the exponents must be equal in this case. So 14 minus 14x equals x squared minus 25x plus 44. Okay. And now this is no longer an exponential equation. This just became an equation, a quadratic equation. So we're back in the comfort of our algebra class. So we want to get we want to get all the terms. What? How are you doing that? Yeah. How do you or I think those are the answers. Yeah. How'd you know that that's the answers?
I just added it.
You already did it?
Yeah.
Okay. Just now or?
Just
Oh, dang. Well, that's good. 30. Okay.
I got you.
So we get all the terms over to one side, have it set equal to 0, and then we can factor the right-hand side. What are 2 numbers that multiply? Do you have the answers up right there? Okay. Oh. I'm sorry. All right.
it's like, I just use the formula but in my head, but don't worry.
Okay.
So actually,
Alright. Okay, so what two numbers multiply to positive 30 and add up to negative 11?
Well.
Yeah, -5 and -6. Very good. And so we can set each of the factors equal to 0. Add 5 to both sides. Add 6 to both sides. And those are our two solutions.
Can these ones be exchanged or no? But like, you know, it's like, reading a book in the piano, like,
Yeah.
you have to like, put that in formula.
Yeah. No, these will not be
Exchanged.
extraneous solutions, yeah. Alright, good. All right. Ooh. Questions on that? I forgot who asked that one. 25? Sure. All right, so 25, so is slightly more challenging actually, because just slightly, because it was very convenient that both of these exponential expressions could be written with a base of 10, right? So we did that, we put them both in a base of 10 and we set the exponents equal to each other, and then it was just quadratic equation from there on out. Here, 5 and 12 cannot be written with the same base. So we have to do something different for this one. What can we do?
LCM?
Yeah. Did it take the log? Okay.
Yes, we have to take the log of both sides because the indicator here is that the exponent has the variable. So we can't really like divide by, 2x or divide by 2, try to get the variable by itself. It's in the exponent. We need to get it down from the exponent first. And there was a property of logs that allowed us to do that. Yeah, if you take the log of both sides of this equation, there was a property that said this exponent can come out to the front. Same thing with that exponent. Yeah, so this becomes negative x plus 10 times the log of 12 equals 2x times the log of 5. Okay. And then I'm not sure if you remember these, from when we did them in class, they were a little bit long, these problems, or I had a lot of writing, but that's just kind of the nature of this problem. We distribute the log, we get negative, or the opposite of x times log of 12 plus 10 log of 12 equals 2x log of 5. We get all the terms that have an x on one side. I'll add the x log of 12 to both sides. So we get 10 log of 12 equals 2x log of 5 plus x log of 12. And then what was this step here that we did next? We have all the terms with the x on one side. And then we factor out an x. So x times 2 log of 5 plus log of 12 equals 10 log 12. And then we divide, by that number next to the x. It's an ugly number, but so the answer would be 10 log 12 divided by 2 log of 5 plus log of 12. Oh, and okay, good. It says write the exact answer using either base 10 or base e logs. So that's what we did. We did base 10. All right. Ooh, good thing I didn't say something else, because there are other ways. You can use other base logs to do this problem.
So you can use ln.
You could even use log base 5 if you want to. Yeah, there's actually nicer ways to do these problems, like simpler ways, but yeah, then we have to go over some property that we actually didn't cover because it didn't really come up in our worksheet. It wasn't necessary, I guess I would say. All right. So just kind of curious here, let me approximate this value. Let's see if I can do it on here. 10 log of 12 divided by 2 log of 5 plus log of 12. And I'm getting approximately 4.3565 on my calculator. 66, yeah. Okay, 66. There you go. And so I can plug in this number into the exponent and make sure that both of these expressions come out the same. So what's 5 raised to the 2 times, I'm just going to write 4.3. Yeah, 5, 6, 6. And then 12 raised to the negative 4.3566 plus 10. Let's see what we get there. So I'll do it on my calculator here. 12 raised to the negative 4.3566 plus 10. Oh man, that's a big number. 1,230,000, something like that, 981. That's that's a big number. Okay, and then 5 raised to the 2 times 4.3566. 1,231,020. They're off a little bit, right? Because we approximated this value here, yeah. So this is an approximate value. Well, we gave the exact answer right there. So, but it does at least give us a little bit of assurance that it's right. Yeah. If it had been anywhere, if it had been, you can see even with an approximate value, we approximated it to like 4 decimal places, and it was, a little bit off. So that tells us that the exact answer is right. Otherwise, it would have been way off if we were in any way wrong. All right. Questions? Yeah, any questions on that? All right, maybe one more if anybody wants to see another one, or 27? Yes, we can. Okay. 27. Let me write 02D next to this one too. 27. Suppose that $2,600 is initially invested in an account at a fixed interest rate, compounded continuously. Suppose also that after 4 years, the amount of money in the account is $31.45. Find the interest rate per year. Write your answer as a percentage. Do not round any intermediate computations and round your percentage to the nearest hundredth. Okay. So what's the formula that we're going to use for this one? Okay. I think I heard somebody say it. A equals PERT. P-E to the R-T. We used it earlier, I think. When it says compounded continuously, if we're talking about money, more than likely we're going to use this equation right here. Okay, so what are the values that were given to us? A, what's A? That's the later amount. And then what else? The principal, that's the initial amount, is 2,600. Good. And then what else?
And then 4 years
time is 4 years. And then we were not given the rate. We're told to find the rate. So R is the question. We're not sure what R is. Okay, good. So let's go ahead and just zoom in here. And let's plug in these values. 3145 equals 2,600. E to the R times 4. And so if we divide by 2,600, we're now just trying to solve for R. So we get 3145 over 2,600 equals E to the, I'll write it as 4R. How can we solve this equation? Yeah, there's an exponent that has a variable, so we probably have to apply the log, right? That's what we did in one of the previous problems. Might have been the one right before this, yeah. So we can apply log. Is that okay?
Can we use log?
We can use any log. Do we want to use ln?
No.
Okay, you want to use log. The answer could actually be it would actually be quicker to use ln, but we can use the log base 10. That it'll still work. Yeah. So remember that the 4r can then come out front once we apply the log. So we get log of 3145 over 2600 equals 4r log of e. And so then what do we do? Divide by log of e and 4. Yeah, let's cancel out the 4 at the same time. So we'll divide by 4 log of e. And so our interest rate, is equal to the log of 3145 over 2600 divided by 4 log of e. This would have been a little bit cleaner that if you had to use natural log, but either one will work. So let me approximate this here. So you'll have a calculator probably given to you, 3145 for this kind of problem, because there's no easy way to do this without a calculator. Divided by 4 log of e. And what do I get? 0.04757 right? Okay, so something like this. It does say right there, round to the nearest hundredth, and write your answer as a percentage. So if we move the decimal place over 2 places, we get 4.76%.
Well, if you round before you move it, then
No, I moved it. And then,
that's what I'm asking, if you round before you move the decimal.
yeah. Yes, because if you round it to the nearest hundredth, it was the 0.05, right? And then that would be 5%, right?
Yeah.
And notice the way that it says it. It says, write your answer as a percentage. It says that first. And then it says, do not round any intermediate computations and round your percentage. Percentage to the nearest hundred. So convert it to a percentage first, and then round that to the nearest hundred. 4.76. 4.76. Yeah. All right. Very good. Okay, maybe we'll stop here and